Welcome to the course of Fundamentals of Artificial Intelligence. This is the first lecture on Introduction to AI. In this lecture, we will look at the quest for AI, the thoughts, ideas, work that have influenced the growth of artificial intelligence. Thereafter, we would look at the definition of AI and the different dimensions of artificial intelligence. We would look at what is involved in an AI system and try to understand the difference between weak and strong AI. We would also very quickly go through different developments in the history of AI. The quest for artificial intelligence is a story of dreams and begin with dreams as all quests do. People have long imagined machines or devices that could reason and have abilities like the human, automatas that could move. In fact, human-like automatas are described in many stories and are pictures in sculptures, paintings and drawings. Perhaps the greatest of the thoughts was described in The Politics by Aristotle. He thought of tools that could perform his task at our bidding or itself, shuttles in a loom that could fly to and fro, and in fact had generated the idea of having automated machines. It was Leonardo da Vinci who sketched designs for a humanoid robot in the form of a medieval knight around 1495. It's very difficult to be sure, and no one knows whether Leonardo da Vinci or his contemporaries tried to build his design. Leonardo's knight, nevertheless, was supposed to be able to sit up, move its arms, and opens its jaw. It could do everything that a human did in its mechanical form. In fact, in 1651, Thomas Hobbes published his book Leviathan. And in that book, Hobbes seems to say that it might be possible to build an artificial animal. And because of that, George Dyson refers to Hobbes as the patriarch of artificial intelligence. In Leviathan, Hobbes writes that life is but a motion of limbs. Why may we not say that all automatons have an artificial life? And he continues to say, what is the heart but a spring, and the nerves but so many strings, and the joints but so many wheels, giving motion to the whole body? It seems Thomas Hobbes in Leviathan actually described the possibility of artificial life. Several people constructed actual automata that moved in startlingly lifelike ways. Perhaps the most sophisticated of these was a mechanical duck, which could quack, flap its wings, paddle, drink water, eat and digest grain. This is what the duck looked like. So in 1738, French inventor and engineer Jacques de Vaucanson displayed the duck, his masterpiece. In fact, very shortly after that, 1801, French silk weaver and inventor Joseph-Marie Jacquard invented the automated loom. Starting with Aristotle's idea in The Politics, we had a real loom that's controlled by punch cards. It revolutionized the mass production and was in great use across Europe. Frank Borman in 1900 invented one of literary world's most beloved robots, the wonderful Wizard of Oz. This was a mechanical man and in search of a heart. Not only in fiction, but in real life, these things were supposed to become reality soon. Some 17 years after Frank, Joseph Kapok wrote the short story Opilock, describing automatons. And Joseph's brother, Karl, introduced the term robot in the play Rossum's Universal Robots. This is when we started having humanoids with brains, albeit in fiction. Rossum's Universal Robot centers around a mad scientist who tries to get the powers of God, for man has acquired the technology and intelligence to create life. Not in fiction, but in reality. Two important tortoise-like robots, Elmer and Elsie, revolutionized the growth of AI. In 1948, Dr. W. Gray Walter was interested if these robots could model brain functions. And he built two small robots, which we called tortoises, and he named them Elmer and Elsie. Elmer and Elsie were a marvel of the day. They were the most revolutionary things because they did not have any pre-programming. And the most interesting thing was that in spite of having basic analog circuits, they could go and research their own batteries when they felt that the batteries were running down. Perhaps this was a turning point in the history of the quest for artificial intelligence. What then is artificial intelligence? We say artificial intelligence is demonstrated when a task that is performed by a human and thought of as requiring the ability to learn, to reason, and solve problems can be done by a machine. This is itself a deep philosophical question. Attempts to systematically answer it will fall within the foundations of artificial intelligence as a rich topic for analysis and debate. This is not the aim of this lecture. So we will, for the time being, have a provisional answer. A provisional answer could be the following. Artificial intelligence is the field devoted to building artifacts capable of displaying in controlled, well-understood environments and over sustained periods of time behaviors that could be considered to be intelligent, or more generally, behaviors that are at the heart of what it is to have a mind. Two things are very important in this working definition of AI that we go forward with. We need to look at behaviors that we consider to be intelligent. There may not be anything of a human brain there. But then we also look at behaviors that we believe that at the heart of it, we need to have a mind or a brain. This is itself a deep philosophical question. This gives rise to further questions. One, what exactly constitutes intelligent behavior? Two, what is to have a mind? Three, how humans actually manage to behave intelligently? Let us look at each of these questions one by one. How humans actually manage to behave intelligently? This question is empirical. It is predominantly for psychology and cognitive science to answer. However, this is a very pertinent question for AI. This is because any insight into how the human thought process works may help build machines that work similarly. In fact, it's very difficult to separate out the growth of cognitive science and the growth of AI. Each have lended help to the other, and their history is intertwined. The next question on what it is to have a mind is a question that what is the mark of the mantle, and is a philosophical question. The trust on artificial intelligence has lent significant urgency to it. In fact, very careful philosophical contemplation of that question has influenced the course of artificial intelligence itself. The third question, what exactly constitutes intelligent behavior, is the question specifying precisely what it is to count as intelligent. This has been traditionally met by proposing particular behavioral tests whose successful passing would signify the presence of intelligence. Let us now look at the dimensions of artificial intelligence vis-a-vis these three questions. So we could have four different things involved. It would be like whether something is thinking, acting, or it is giving rational behavior, or it's giving human behavior. So an artificial system could either fall into one of these four ways of looking at things, and therefore we could have systems which would be thinking humanly, or thinking rationally, or acting rationally, or acting humanly. Think like human, when we say, we mean we need to model human cognition. Think rationally would involve formalizing the inference process. To act rationally would mean doing the right thing always. And the fourth, act like human, would involve exhibiting human behavior. Let us look at each of these dimensions one after another. The first one, thinking like the human, involves modeling human cognition and is an area that has been looked at very closely by the information processing community within psychology and has got an huge push from the cognitive revolution. It requires scientific theories of internal activities of the brain. In fact, Newell and Simon's general problem solver is a kind of these intelligent system. The general problem solver, developed in 1957 by Alan Newell and Herbert Simon, embodied a grand vision. It thought of a single computer program that could solve any problem, given a sustainable description of the problem. It did cause quite a stir when it was introduced. And many people felt it would sweep in a grand new era of intelligent machines. It's a different story that it didn't happen the way it was hoped to make its contribution. The next dimension of artificial intelligence is about thinking rationally, which involves formalizing the inference process. In fact, there are several Greek schools which develop various forms of logic, notation, and rules of derivation of thoughts. They may or may not have proceeded to the idea of mechanization of these processes, but the very idea of formalizing the inference process has a direct line through mathematics and philosophy to modern AI. In fact, Aristotle has a huge contribution here. Aristotle considered rationality to be an essential characteristic of the human mind. Perhaps the deepest contribution of Aristotle to AI was the idea of formalism, notion that remains at the heart of contemporary computational theory of mind and what we will see later to be strong AI. The idea of an intelligent machine was often thought to be a machine that can perform logical inference. Aristotle was one of the first to attempt and codify thinking. His syllogisms provided patterns of argument structure that always give the correct conclusion given correct premises. Let's take an example and see what it means. Here is an example which says that all computers use energy. We could then say using energy always generates heat. And from these two sentences, we could draw a conclusion that all computers generate heat. Aristotle told us how to do it in a pattern of argument structure. But then there are many obstacles to the logistic approach in building programs to create intelligence. They are, number one, not all intelligent behavior is meditated by logical deliberation. Number two, if everything is logical deduction, question is, what is the purpose of thinking? What thoughts should I have? Informal knowledge is not precise, and therefore under a logical premises, it's difficult to model uncertainty. Number 4, the theory and practice of putting everything within a logical system is hard to put together for real life problems. Let us now focus attention on the third dimension of artificial intelligence, which is act rationally, that is, doing the right thing. Rational behavior or doing the right thing is where one is expected to act to maximize goal achievement given the available information. Now, many of our rational acts do not necessarily involve thinking. Most of the bionic reflexes that we do, like if your glass is slipping out of your hand, you just re-grasp it with more pressure. We do it without thinking. So they do not necessarily involve thinking. It is definitely more general than the logical approach and amenable to scientific development than approaches based on just human behavior or human thought. However, achieving perfect rationality in complex environments is not possible. This is because of the high computational demands that such systems put. We now focus attention on our fourth dimension, which is act like human, that is, exhibiting human behavior. Creating machines that perform functions that require intelligence when the same functions are performed by people. There are a number of capabilities to be incorporated in such systems that need to act like human. They include things like natural language processing, knowledge representation, automated reasoning, machine learning, computer vision, and of course robotics. It was Alan Turing who published his landmark paper in which he speculated about the possibility of creating machines with true intelligence. He noted that intelligence is difficult to divide, and therefore he devised the famous Turing test. In fact, the Turing test was the first serious proposal in the philosophy of artificial intelligence. In his paper, Computing Machinery and Intelligence, Alan Turing starts with the words, "I propose to consider the question, can machines think?" And he laid the ground for what later became to be known as artificial intelligence. The Turing test, or the imitation game as it was called in the paper, was put forth as a simple test that could be used to prove that machines could think. The Turing test involves the following. There is a human interrogator talking to a human or to a machine, unaware of whom he gets responses from. If the interrogator is not able to distinguish the responses received from the man or the system is said to be artificially intelligent. Turing also has a lot of contribution apart from this in the history of AI. Turing and his fellow code breakers were actually pitted against the Nazi code machine Enigma. And Turing put up electromechanical machines to read thousands of German radio intercepts. In fact, these machines employed something which we now have as a central idea of AI called heuristic searching. They found the right answer often enough and fast to be read in real time. In fact, without such machines, German U-boats would have decimated the North Atlantic convoys.